Hi students, you've heard us talk about radians. We've been converting our calculators out of radians to degrees. So what is a radian? Now radian is an angle measure based on arc length, and it's far more mathematically legitimate, I should say, than degrees. I think degrees is a man-made construct, just an arbitrary measure. I don't know if it's based on how many days a year in the old moon calendar. I've heard different things and I'm not sure, but I want to show you what a radian is. So I have this applet right here I found on the internet, and I'm going to show you what is a radian. Notice they cut a radius, and they take the length of that radius and they lie it along the arc. The length of that radian, the arc that is subtended right there, that angle measure is called a radian. So hopefully you understood that. Let me say it again without the fancy schmancy. This is the length of a radius. It changes with every circle, but of course they're all similar, so this radian will hold true. This property will hold true no matter what the size of the circle. If I take this length and say, okay, I'm going to put it along here. So I want a radius length on the side. So this is one radius, or radian. If I create an angle with this arc that is the length of a radius, this is called a radian. That is an angle measure. Instead of degrees, it's number of radians. And just like a circle has 360 degrees, there's a very set number of radians for every circle, which is pretty cool. Let me show you. Again, I'll go to that applet. It says how many degrees in a radian. So watch what they do when they take the radians and put it along the edge. On 180 degrees, they get 3 of those radiuses and a little change. Look what it comes to. Pi. Isn't that cool? So that means there are 3 and some change, or pi number of radians in half a circle. Therefore, for a full rotation would be 2 pi, which I think is pretty neat. So there are 2 pi. Now we already knew this mathematically, we just hadn't realized it yet. Because if we had a circle and I said, what is the circumference around it? You would say diameter times pi, or 2 times r times pi. That's what we've always known was the circumference around. Well, if we were saying, okay, so how many radiuses are around? Then, and you divide it by radiuses, the r, look, you have 2 pi. So that kind of makes sense, hopefully, now. So there's 2 pi radians. So let's cut to the big question. How do you convert from degrees to radians and vice versa? Well, it's really easy, sort of. If you have, let's say there's 2 pi, that's how many radians are in 360 degrees. So let's find out how many radians are in 1 degree. So first let me divide both sides by 2, and I'll make pi radians is equal to 180. So 180 degrees, so 1 degree would be pi radians divided by 180, right? So that's what we're going to use. Radians is going to be my unit of measure, so I'll put it out here. It's going to stay, I don't want to cancel it. So it'll be pi over 180. So let's do some examples. Degrees to radians. First, write your value. Well, let me do it with 90. I want to show you something on this unit circle really fast, I promise. So let's say you had 90 degrees. And I told you had to multiply that by pi over 180. It's really 180 degrees, but the degrees are going to cancel, correct? And 90 over 180 will cross reduce. I'm multiplying. That'll become 1, that's 2. So it's pi over 2, which makes sense. If from 0 to 180 degrees is pi, then pi over 2 would be 90 degrees. So if I had, let's do just another arbitrary number. Let's just say 100 degrees. Write your value, multiply it by the conversion factor of pi over 180. And I'm not a big fan of doing this, times pi over 180 degrees. I'd rather just kind of compile this in one little algorithm. Is that the word I should use? 100 pi over 180. So I write my value, I put pi over 180 with it, and then I simplify it. So this is going to go away, that goes away. 10 over 18 is 5/9 pi. So I have multiply. I put multiply here. Simplify, multiply, and be sure to note it's radian. Oh, pi, radians. So it's 5/9 pi radians. Let's do one more of these. I'll go fast. Let's say 60 degrees. Write your value, multiply it by the conversion factor of pi over 180. And, 6 over 180 is 1/3, right? So it's going to be pi over 3. And make sure you write radians. So that's how you go from degree to radians. So how do you go from radians to degrees? Well, back here, where'd it go? I don't know where it went, but we had that 2 pi radians was equal to 360. So let's simplify this for radians, right? I want to find out what a radian is. Last time I simplified 1 degree. Now let's do 1 radian by dividing 2 pi on both sides and isolating the word radian. So let's see, 360 divided by 2 is 180, right? Over pi. Well, that makes sense. If I go from degrees to radians to go by multiplying by pi over 180, then I do 180 over pi to go from radians to degrees. So that's going to be my unit factor. Write the value. Let's say I have 2 pi over 3 radians, right? Multiply it by 180 over pi. And what will happen every single time is the pi signs are going to cancel. And now I just have to cross reduce. Let's see, 3 goes into 180 60 times, and I have 120 degrees. Let me do another one. Let's do 3/4 pi. Now I always remember this because I know that the pi is going to cancel, so I know it's on the bottom. And it's always 180 in pi, so it's really easy to remember this. Pi cancels. Let's see, 4, both of these can be divided by 4. 4 becomes 1, and I half this to 90, half it again to 45. And I have 3 times 45, which is 120, and 15, which is 135, I hope. So, and you have to make sure it's degrees. So there you go. 8 minutes, gotta go, take care.